This example is asking for the area of a circle, and there's a really nice way of working out the area of a circle. Um, if you take a normal circle and you cut it into quarters, for example, and you arrange it like this, you put one quarter like this, and then you put another quarter upside down underneath, and then another quarter on top, and then another quarter underneath. It looks a bit like this, and we can see that if we start cutting the circle up a little bit more and arranging it in the same way, I do the first wedge like that, and then the second wedge underneath, third wedge, fourth wedge, fifth, sixth, seventh, and eighth. Then these two shapes would have the same area. But this one looks a little bit more like a parallelogram. That side there is parallel to this side there. And okay, it's a bit bumpy, but it's a lot less bumpy than it was to start with. And if I keep cutting this circle up into smaller and smaller and smaller bits, it eventually does become a perfect parallelogram. And this parallelogram is actually oblong. And we may see that the distance around the outside here, all the way to that point, is the same as the distance from here all the way to that point. And we can also see that the height of each wedge actually represents this side here. So you may remember from the definition of what pi means. Pi represents how many of the diameters you need to go all the way around the outside. And this gives you the formula. The circumference is equal to pi times the diameter. And the diameter is the same as 2 times the radius. So that's why I can put the 2 in the front, 2 pi r. This is where this other formula comes from. And the circumference is all the way around the outside, but the blue line here, that represents half the diameter, half the circumference. And half the circumference is just pi r. So this length along the top here, this is pi r. I'm going to do that in blue. So pi r is that length there. The white side, that's going to represent the radius. So I can write here r. And the area of this whole rectangle would be pi times r times r. And I'm going to write just pi r squared. So that would be the area of this rectangle, and that rectangle is the same as the area of the circle. And that's why we get this formula, pi r squared is the area of a circle. So we can use this idea to work out what the area of a circle would be if its diameter was 10. Well, first of all, we can't use diameter in this formula. We have to work out what the radius is. So if the circle had a diameter of 10, what would the radius be? Well, the radius goes from the center to the outside. So the radius, if the diameter was 10, the radius would be just a half of that, which is 5. And we can use the radius in this formula to find the area. Five squared is 25, and I'm going to write it 25 pi. You normally write the number before pi, so just to get in the hang of doing that. The units, of course, would be meters squared, because the diameter is in meters. An area is a squared unit. So the area, would be 25 pi meters squared. I could put this into a calculator and approximate it, but if I were to do that, I'd have to write something like 3SF. But I want to leave it exact, and this is the exact form.